This is 15-Minute Fundamentals, where we interview core contributors within crypto and gain insights into their day-to-day operations. In this episode, I'm joined by AJ Warner, Chief Strategy Officer at Offchain Labs, which is the team behind Arbitrum, a Layer 2 smart contract platform for decentralized applications on Ethereum. Similar to how not all companies in the world operate in a single jurisdiction, not all DAOs will operate on a single blockchain. Given the limited capacity and use cases of a single blockchain, we're going to see a world where multiple different blockchains interoperate with each other, with each chain being optimized for different kinds of use cases. Arbitrum is built to specifically scale Ethereum, enabling lower costs and 7 times more throughput than mainnet itself, while maintaining the same level of security. In this episode with AJ, we discuss what Arbitrum is and how it's positioned within the scaling solution market, how both Arbitrum One and Arbitrum Nova work under the hood and what makes them unique, why there's a need for several blockchains in the first place, the team behind the project, current growth drivers, and more. Hello, AJ. Welcome to 15-Minute Fundamentals. I'm super excited to get to dive into Arbitrum today.
Hey, thank you so much for having me, Oscar. It's a pleasure to meet.
Awesome. Now, before we start diving into the details, let's just cover the basics. Could you give us a quick introduction to Arbitrum for anyone not yet familiar?
Sure. So Arbitrum is an optimistic rollup solution, and its purpose is to scale Ethereum. So I'll unpack what that means for a quick second. Ethereum, by design, does not scale. It prioritizes security and decentralization. We have a concept called the blockchain trilemma, where there's security, decentralization, and throughput. And it's not really possible to have all three. And an easy way to understand that is if you have a lot of throughput, the cost of running the nodes is going to go up, which means less people will be doing it, which means that there is going to be less decentralization amongst the people that are running nodes. So Ethereum by design caps the number of transactions that it can do. And the way Ethereum scales is through a technology called rollups. So what does a rollup do? It's a set of smart contracts. That's what Arbitrum is. It's a set of smart contracts that lives on top of Ethereum. To users, it looks and feels exactly like a blockchain. But under the hood, it takes all of your transactions and posts them to Ethereum on your behalf. And the key secret sauce here is how do you tell Ethereum that what happened on Arbitrum is true, correct, and complete? And that is what we call a proof window, essentially, where somebody can challenge and say that the batch that was posted by a validator is incorrect, the state is incorrect of a specific transaction or a specific instruction, and you have a challenge period where another validator can say, well, actually, that's wrong, this is the correct state, and Ethereum basically adjudicates what happened. So what people say is, this is Ethereum's roll-up-centric roadmap. What they mean is we're going to separate the storage of data, which exists on Ethereum, and the execution of the contracts, which exists on Arbitrum, and allows Arbitrum to be a much higher throughput environment for Ethereum and then compresses the data and batches it there. So, Arbitrum does about 10x the Ethereum capacity of transactions and compresses all that data and posts it to Ethereum on behalf of its users. So that's the high level of how sort of an optimistic rollup works. And Arbitrum, the first product, Arbitrum One, which is like the core rollup that most people are familiar with, and we'll talk about our other product, Arbitrum Nova, probably later. It's been live for a year and a half. It's become a hub for DeFi innovation, mainly because of its ability to have intense computation for derivatives and options that could not be viable on Ethereum, while being in an Ethereum rollup, so people have the confidence of Ethereum when they do these transactions, and it's attracted a lot of liquidity. So that's sort of the high level. I'm sure we'll talk about some of these things more as we go further on, but that's Arbitrum in a nutshell.
Thank you so much for that comprehensive overview. So we got both the what is Arbitrum, also a look into the purpose of your being, why we need scaling solutions, and then also the core product there. Now, it would be great if you could describe the scaling solution market in general, and especially from the perspective of Arbitrum's position within it. You mentioned optimistic rollups, but there are also other solutions out there. So both how optimistic rollups are positioned within the whole mix, and then you within the optimistic space.
Ethereum by design, if we go back again to 2020, let's call it DeFi summer, Ethereum was extremely congested and rollups were not there. So new flavors of alternative block space were in high demand. Forms of that include, for example, the proof of stake Polygon, the POS sidechain, which has seen a lot of traction and success. Alternative layer one environments completely like Avalanche and Phantom of the EVM flavor. Solana, which is a layer one blockchain that instead of its Solidity, you write in Rust, which has its own advantages and trade-offs. So you have scaling through alternative layer ones and sidechains, and then you have scaling through what we call roll-up or layer 2 technologies. And the definition of a layer 2 is always, very debated depending on who you ask. But the way I like to think about it is Does it leverage the security of the base chain? Is it posting data to Ethereum as a base chain? Is it posting its consensus to Ethereum as a base chain? And that is an environment that's really dominated by three different types of solutions. So you have ZK rollups, you have optimistic rollups, and you have rollups that use alternative data availability committees, which, Arbitrum has a product that does that as well. And we can talk about that in a minute. And in terms of what the scaling solutions in the landscape looks like, we've seen some success with ZK rollups in an application-specific environment. Probably the best examples are like EYDX and maybe ZK Sync 1.0, which was focused on like payment transfers. If you want to do general smart contract platform execution, have the ability to deploy any applications, optimistic rollups are much further along and much more mature than ZK rollups. The ZK rollups are, sort of starting to come to market. I think next month, Polygon and I think ZK Sync have both announced that, but optimistic rollups have been alive since, the middle of 2021, have continued to mature and have continued to improve. I think one thing that the ZK rollup teams like to do is sort of compare optimistic rollups in a specific moment in time to what a ZK rollup might look like, but the optimistic rollups have seen significant evolution over time and could continue to show the value proposition for using them. Arbitrum is currently at about 53% of rollup market share from a liquidity perspective, probably more so than that even on a trading and DEX volume perspective. The statistic I'm always most proud of is the amount of ETH that's been bridged into the Arbitrum ecosystem. There's about 920,000 ETH in the Arbitrum bridge, which is more than basically all scaling solutions combined. From a liquidity perspective, it's allowed the ecosystem to really shine. But the third one is, using alternative data availability committees, and we'll talk about that for a quick second. One thing that rollups do very well is getting fees of using Ethereum down a lot. So a transaction, let's say a Uniswap trade on Ethereum might be $5. On Arbitrum, it might be 15 cents. But for some use cases, 15 cents is still too expensive. And this is true particularly in social and gaming verticals. And what we did was we launched another chain called Arbitrum Nova, which uses what we call the AnyTrust technology. And there's only one difference between Arbitrum One and Arbitrum Nova, and it's, does it post the call data to Ethereum or does it post the call data to a data availability committee? And Nova posts it to a data availability committee, and then the data availability committee posts a certificate to Ethereum, basically assuring that it has the data. And that brings the costs down by about another order of magnitude. So transactions on Arbitrum Nova are 1 to 2 pennies. And it goes with our thesis that there's not one blockchain architecture that solves the decentralization blockchain trilemma in a specific way that will solve everybody's problems. You need different flavors for different use cases. And DeFi protocols, need a higher level of security and have the ability to spend more on transaction fees than a game that might have, very cheap transaction fee requirements because the developers are abstracting gas from their users or because the assets that are being traded are not very valuable. And we've designed Arbitrum technology to be able to be supportive of both of those technologies. And I think that is an important component of what we call like a modular Ethereum ecosystem that can allow for that to interoperate with Ethereum.
Okay, that's super interesting. Can you speak a bit more about Arbitrum Nova and the use cases that you've seen for it?
A 5-cent transaction on Arbitrum One, if you're a GMX user, is irrelevant. If you're doing a trade of significant value, right, you care much more about the borrowing rate. Or if you're doing a DEX trade, you care about slippage, right? The transaction fee is not a major component of your decision whether or not to make the trade. It is on Ethereum, but it's not on Arbitrum. But if you're a gaming or a social platform where you might be doing 1 million transactions a day, and these transactions are not intended to be economic in nature, they're intended to be, saving the state of a game. They're intended to be, a POAP for attendance of a party. 5 cents could impact the business of that product. And they don't need all of the data posted to Ethereum. So we've designed the AnyTrust chain, which we think in comparison to a typical sidechain is a much better design. I'm happy to talk about some of those differences if you think it's interesting, to allow these other use cases to survive and thrive. So for example, we're working with the Reddit team on their community points. They're using Arbitrum Nova. On the first day that they launched with the cryptocurrency and Fortnite subreddits, they were seeding tokens to 250,000 wallets. It cost them in aggregate about $1,700, so less than 1 penny per wallet. If that happened on Arbitrum One, it would have been tens of thousands of dollars. If it happened on Ethereum, it would have been hundreds of thousands, maybe $1 million, right? And for their use case, for what their vision is for the product, Nova was the right fit, and it was preferable to something like a sidechain, but the roll up was from a justification perspective is just unnecessary for them.
It would actually be really interesting to hear about the differences in design between Nova and a typical sidechain, and then what you see as Nova's advantages as well.
From a smart contract perspective, the code is basically the same. The only difference is who has access to the data. So on Nova, on any trust chain, there's a committee of actors who have access to the data. And that committee on our public chain right now and I'll talk about the trust assumptions in a second. That committee is Offchain Labs, Reddit, Google Cloud, Consensus, QuickNode, OpenSea, and P2P, the team who developed the validator product. They worked on Lido and other ecosystems validators. And the trust assumption is that as long as one of those members is holding your data, you should have confidence that your data will be there. And those members are posting certificates to Ethereum stating that they're holding the data. The design and the project that we put together, we've tried to get a mixture of Web 2 and Web 3 projects so that anybody can kind of get confidence that, if you're a user of Reddit, you have confidence that Reddit holds your data because they hold all of your Reddit data. If you're a Google Cloud user, if you're a crypto user and you don't want to trust sort of Web 2 institutions, well, hopefully you have more confidence in either Offchain Labs or in Consensus, or if you're an NFT user in OpenSea. And the trust assumption is you just have to trust one of them. And the reason for that is because any validator has the ability to force the protocol into a rollup. So if there's a malicious attack on the network, progress is not halted as long as one of the validators who's still holding your data in his function as a committee member can force the protocol into a rollup. And then data is posted to Ethereum and progress will continue. That's from a liveness perspective compared to a sidechain, that's one of the big advantages. The other big advantages around compared to a sidechain is really about the formation of cartels. And what I mean by that is, and I'll give an example. If you have 10 validators in a sidechain and you say, I want to decentralize this more, I want 100. If it's a typical sidechain that has like a 2/3 honesty assumption, what happened was you needed 7 honest actors. And now what you'll need is 70 honest actors, right? So you should hopefully be able to get 70 honest actors. But in reality, what you've done is you've introduced a potential attack, because if the 90 that you've added when you went from 10 to 100 were able to obfuscate the relationship that they have, and let's say they were all one entity, right? All 90. They now have an attack vector where somebody can halt the chain because they can break the consensus. In any trust model, if I went from 10 validators to 100 validators, as long as I trusted one of that 10 originally to force the protocol into a rollup mode to keep my data, it doesn't matter how many bad actors you've added, because they don't influence the ability of this one actor to force it into a rollup. So that's one of the big technical distinctions and innovations that these chains, or these data availability committees and the design of Arbitrum AnyTrust have. And from a cost perspective, unless you're in that rollup mode, which you shouldn't be, unless you are in that rollup mode, the cost of using the chain is the same as a sidechain, because you're not posting the data to Ethereum.
Got it. That makes sense. Now, going back to Arbitrum One for a little bit and taking a more technical perspective, could you describe the most important smart contracts and events within Arbitrum One's smart contract infrastructure?
The way you can think about this is, let's take it from a user's perspective. So how do I get my funds into Arbitrum, right? How do I enter the Arbitrum ecosystem? And there's a lot of different ways. So right now, most, if not all, of the major centralized exchanges have direct onboarding into Arbitrum. This past week alone, Coinbase and Kraken both announced support for ETH and a couple of other assets. Binance, Bybitcrypto.com, KuCoin, most major exchanges have support. So if you want to onboard into Arbitrum, through your centralized exchange, you can, but from a technical perspective, let's focus on sort of what happens if you are already on chain. So let's say you're on Ethereum and you want to bridge into Arbitrum. What you really are doing is bridging your asset into a smart contract that lives on Ethereum and mints an asset on Arbitrum. And it's different than, bridging to a sidechain where there might be a multi-sig wallet or a trusted intermediary that is holding the asset in that bridge. It's a smart contract on Ethereum, right? Because all of Arbitrum is a set of smart contracts on Ethereum. So when you bridge in, you bridge out, you can always call your funds back from Ethereum layer 1 when they're on Arbitrum, because that's the nature of the bridge. So that's how you get into Arbitrum. When you are on Arbitrum, let's just say you want to do a swap on Uniswap, just for the simplicity. What's happening in terms of a transaction lifecycle is there's a couple of different steps. In the architecture, there's something called a sequencer, which is basically taking your transactions and giving you what we call a soft finality and saying your transaction is confirmed. And if any of your users have used Arbitrum, it creates almost like a Web 2 experience. It's incredibly fast. The sequencer is producing blocks on Arbitrum every 250 milliseconds. So it's a really strong user experience for the users. And that's step one, right? So you have this soft finality from the sequencer. What the protocol then does is it takes your transactions and it's executed by the sequencer and it batches them with thousands of other transactions. And you can see like on the block explorer, if you go to like Arbiscan, the batches of transactions, it will take 1,000 transactions. We probably do this on average, depending on the demand on the network, on average every 2 minutes or so. And we post those transactions to Ethereum on behalf of the users. And it's just what we do is we optimize for posting the compressed call data, because the most expensive component of using Arbitrum is posting data to Ethereum. And the more that can be compressed when it's posted, the cheaper the fees are for the user. So we want to post whatever we can to recreate the state of Arbitrum on Ethereum, but we don't want to post anything that's not necessary. So we compress post to Ethereum as a batch, and a batch might be 1,000 transactions that cost $60, and that's amortized over the costs of using the network. And what happens in an optimistic rollup at that point is a fraud-proof window is opened, where for 7 days, anybody has the ability to challenge what was posted to Ethereum. Any validator of the system can challenge and say, instead of me giving $1 to Ascari, I gave $2, and the state that was posted was wrong. We actually had this play out on the ep.40 chain actually after the merge. So it's a quick digression, but it's interesting to show how this works. As you know, the merge happened around September, and Arbitrum, because it's a set of smart contracts, after the merge existed on both chains. The ETH POS chain, which we call Ethereum today, and the ep.40 fork, which for a few weeks people were trying to sustain and keep alive. And what happens is there was ETH in the bridge on both of these chains. I think at the time it was around 700,000 ETH, and somebody submitted a malicious assertion on the ep.40 chain and tried to take all of that ETH out of the bridge. I think at the time the ep.40 was trading at $6 a coin, so they thought they would have an easy way to like $4 million worth of ep.40 by submitting an invalid state root on Arbitrum on ep.40. And somebody on our team decided to run a validator and actually challenged this attacker on the ep.40 network, and he lost. And the worthless ep.40 was saved in that bridge. But it was cool to see it play out, like this window where somebody can submit an invalid state root, and we can see the protocol defend. So that's really the transaction life cycle. The reality is you don't have to really wait for that 7-day period in order to get transaction finality, because if you're running an Arbitrum node or a validator, you know what the consensus is, you know what the correct state is from your node, and you should have the confidence to trust that, and that's how most people operate. They run nodes and are processing based off of that.
Got it. And now that we got the full kind of life cycle of an Arbitrum transaction, I'd love if we can add the economic and value flow perspective to that. So could you give us a rundown of who pays fees for what and how they're split between sequencer and Ethereum L1?
Yeah, so the way it's set up is the sequencer, and this is another limitation of the sequencer, the sequencer doesn't have the ability to arbitrarily decide what to charge its users. The sequencer's fees are a function of an oracle that it receives from layer 1 about what the cost on layer 1 of posting the transactions are at a specific moment in time. So the sequencer fee is in many ways set. So the sequencer charges X, and there's like a little bit of margin, but it's not designed to really be a significant margin. It's just you don't want the sequencer to be losing money. The sequencer collects from users, then the transactions are batched and posted to Ethereum layer 1, and whatever is posted to layer 1 is the cost, and whatever is the delta is accrues basically to the sequencer.
Okay, got it. Next, I'd be really keen on hearing what the team looks like building Arbitrum.
It's a good question. So I'll talk a little bit about the history and the roots of the project. And I'll start there. So the project was founded in Princeton. So Ed was one of the co-founders. Ed Felton was the chief scientist at Offchain Labs now. He was a professor at Princeton. And before Ethereum was even founded, he was reading the smart contract white papers, the smart contract blockchain white papers, and immediately realized that this was never going to scale on layer 1 because he understood the blockchain trilemma. And he dedicated actually his class in fall 2014, and your listeners can find it on YouTube. It's pretty hilarious. He dedicated his class to designing an early prototype of Arbitrum on like a hypothetical layer 1 that didn't exist, right? He went to the White House. He was Obama's deputy CTO. And when he came back, Ethereum was, an ecosystem that was starting to thrive. And CryptoKitties was the first time that Ethereum ever congested. And together with PhD students, Stephen and Harry, who are his two co-founders now, they decided to, pick up research on Arbitrum again and, make make it into a project. I actually at the time had a small part of that story. So I'm by trade a lawyer, and I was a real estate lawyer in New York before I joined this full time. I was their lawyer. I was helping them through the corporate formation, helping them through a seed raise, and I joined the company full time in 2020. Once there was something to do from a non-technical perspective, I joined to sort of build out the ecosystem when the project was on testnet. Right now we're about 70 people at Offchain Labs working on this. We recently joined forces with Prismatic Labs, which is the team that built Prism, the staking client for Ethereum, and they've been getting integrated into Arbitrum development. So we've about probably, I think, 45 engineers and 25 non-engineers in the company.
Got it. Now, if we pull up your dashboard on Token Terminal, we can see that almost everything is trending up. Fees, active users, revenue. It looks quite nice. Do you want to give us a bit of context to what the main drivers are behind this growth right now?
Yeah, that's a good question. So I think that there's been a lot of explosive growth in the last 3 days in particular. I'm not sure exactly what that growth is. There are a few projects that have recently launched. Camelot Dex has been doing some incubations. Vela recently launched their perps platform. So I think that's been driving a lot of the growth recently. But just our approach generally has been to work very closely with projects and to help scale their ecosystems and grow. And we've been seeing a snowball effect where, things have been picking up. And I think as the infrastructure continues to mature, as centralized exchanges like Binance, Coinbase, Kraken can get their users directly into L2, you get this flywheel of infrastructure, liquidity, DeFi applications, games, and it's kind of just, erupted in an explosion of new users, new applications, and become a playground for innovation. So I don't have a specific thing that I can point to other than to say that I think that our approach to trying to work really closely with projects to identify best-in-class developers and builders at the application layer and support them is paying off for us now with a very strong community of supporters and users that just love the product, love what we're doing, love the ecosystem, and they deserve all the credit for the growth.
That's great. And congrats, by the way, on flipping mainnet in terms of daily transactions the other day.
Yeah, we did it again today. So 2 straight days, and I think that it's a historical moment for the Ethereum's rollup centric roadmap. Honestly, it was a really good feeling because that's what we're trying to do. We're trying to scale Ethereum. We're passionate and dedicated about it, and this was just a meaningful milestone for that to happen. And what I love about it is that it's not competitive, because this is what Ethereum wants too, right? It's not like Ethereum maximalists are disappointed by this. Everybody's embracing this. There's really no reason. This is just a milestone for everyone to celebrate. So it's really amazing to see.
Yeah, it definitely is. Now, are there any data points you could share where you are right now in terms of transaction throughput compared to what it's traditionally been, and how everything's developing on that side?
Yeah, so I don't have the data points right in front of me. We hit 1.1 million transactions in the last 2 days, which is slightly above what Ethereum does. Ethereum does about a million transactions on a typical day. We've been seeing significant growth. I think throughout since 2023 began, we probably were averaging between 400 and 600,000 transactions a day, but this has obviously grown significantly since then. We're seeing a ton of growth in developer smart contract deployments as well. I think we've broke our all-time highs 5 times in the last 10 days of the most contracts deployed to Arbitrum One as well. So you're not just seeing the growth in the users, you're really seeing the growth in deployed contracts to the network as well, which is really great to see, because that's the flywheel effect, right? If you don't have users, are there for the applications. They're not there for Arbitrum, they're there for the applications building on Arbitrum, and the builders want to be able to tap into the liquidity, they want to be able to tap into the users. So it's really great to see both of those moving in tandem, and hopefully it just continues from a network perspective, because people are curious, when do you hit capacity on Arbitrum One? What does that look like? The system is designed to handle between 7 and 10 times the Ethereum workload before any congestion mechanisms hit. So even, I think, the typical transaction on Arbitrum actually consumes a lot more gas than the typical transaction on Ethereum, because a lot of the transactions are perps, which if they did them on Ethereum would be ridiculously expensive. But we still have multiples to go before any congestion would kick in from where we've been for this week. So it's really exciting to see that there's a lot of room to continue to grow the ecosystem out before any congestion mechanism hits. And the reason you have these congestion mechanisms in place is what rollups don't solve for is they don't solve for state bloat, right? You want anybody to still be able to run an Arbitrum node. It's important for people to be able to do that. It's maybe less important than running an Ethereum node, which is the underlying source of data, but you want people to be able to run an Arbitrum node, and we don't want that experience to become impossible for the average user at home.
Now, as momentum's positive, everything seems to be developing in the right direction. Are there any specific challenges you're facing from like a day-to-day operations perspective?
Yeah, I think there's always challenges. It's an incredibly competitive environment. Scaling blockchains, there's a lot of teams that have a lot of capital, that have a lot of great products, and the competition is very high. And I would say, people are really excited about Arbitrum. People appreciate the value proposition of what we're doing, the ecosystem that we've built, but we're always hungry to find the best developers building the best applications to get them to be building on Arbitrum. And that's a very competitive environment. So I would say that's probably the biggest challenge.
For this interview, I have one final question, and that's going to be, what is next for Arbitrum? So what are you currently focusing on? And is there anything you could share from the mid to long-term roadmap?
I would say there's two answers. On the technical side, we haven't talked about it, but we released an announcement for a product roadmap update called Stylus. And this is, in my opinion, the most exciting technical development that's happening on Arbitrum. Right now, you sort of see the landscaping. Everybody's coalescing around the importance of the EVM, right? EVM compatibility, EVM equivalence, whatever term you like to use. You're seeing this especially on the ZK side, right? All this competition, like who has the first ZK EVM, who has the most compatible ZK EVM. Our perspective has always been the EVM compatibility is the floor. Every version of Arbitrum has had EVM compatibility from the first testnet, no custom compilers. It should work. And we've continued to improve what like EVM compatibility means with like our Nitro upgrade and etc. But it's in many ways we view it as the floor. If we want global adoption of this technology stack, the expectation that every developer will only write in Solidity is hard to imagine. And we've seen, for example, in Solana's ecosystem, like the use of Rust, Sui and Aptos use Move, and there's like demand from developers for these other languages. What we're going to do with Arbitrum Stylus, and we just announced it, you can find it, it's actually our pinned tweet on the Arbitrum account. We're going to have multiple programming languages that can live within a single Arbitrum chain. We're starting with Rust, C, and C++. So when it's deployed to testnet and mainnet, you'll be able to deploy a Rust contract to Arbitrum, and it will be able to compose with Uniswap. It's not going to be living on a separate version of Arbitrum. It will be in the same version of Arbitrum. You'll be able to have Rust contracts, C contracts, C++ contracts that will compose with a Solidity contract, and there will be precompiles that are deployed that make things much more efficient from a gas perspective. And from a technical perspective, we think this will unlock a ton of developers, Web 2 users, enterprise, etc., which kind of gets to sort of what's next from a non-technical operations and I would say business development perspective. We've been very focused on very crypto native teams, DeFi, NFTs, Web3 gaming. As the technology continues to mature, as we can introduce other languages, we're going to be more focused, not in lieu of, but just in addition to trying to bring Web3 and crypto and Arbitrum to the world and Ethereum to the world. And that's probably the next challenge for us to tackle.
Awesome. That is fascinating. And I really can't wait to see how everything plays out. You have so many cool things brewing. So we'll definitely do this in the near future again to dive into the details behind all that new stuff that you guys are putting out. Thank you so much, AJ, for taking the time. I know this is a bit of a red eye episode for both of us, midnight for you and 6 a.m. for me, but I think we managed to put together a pretty good overview of Arbitrum. So thank you so much.
Yeah, thanks. Yeah, this was great. 12 a.m. in crypto, right?
Yeah, exactly.